Hi friends, today's topic of discussion is Coleman air refrigeration cycle. So, as you can see over here, it consists of a compressor and the process which is related to compressor, we will name it as process 1-2, and then it goes to the heat exchanger, that is the cooler, and the process which takes place over here, we will call it as process 2-3, the expander. Okay, then the air enters the expander. So here the process we will call it as process 3-4. Then the air enters the evaporator, that is the refrigerator. Here the process we will call it as 4-1. So as you can see, the air travels from compressor to heat exchanger, that is cooler, then to the expander, and then to the evaporator, that is the refrigerator, and again it goes to the compressor. So let us see regarding the PV and TS diagrams. So as you can see over here, this is the PV diagram and this is the TS diagram. So first regarding the compression we will discuss. So as you can see, the compression takes place isentropically. Okay, so therefore this process 1-2 is called isentropic compression process. Isentropic compression. So as you can see over here, we have S1 is equal to S2. So process 1-2, okay, it is isentropic compression process. But as you can see here, because of the compression, the volume reduces, okay, but the pressure increases from P1 to P2, and the volume reduces, pressure increases, and the temperature also increases from T1 to T2. Then the air enters the heat exchanger, that is the cooler. Here this process is called isobaric heat rejection. As you can see over here, okay, the heat is getting rejected in the process 2 to 3. Okay, so here the heat is getting rejected and it is called as isobaric heat rejection, because as you can see over here, the pressure is constant from P2 to P3. Okay, so P2 is equal to P3. So that's why it is called as isobaric heat rejection process. So here what happens, the volume reduces from V2 to V3, and here as you can see, the temperature had reduced from T2 to T3. Okay, then it goes to the expander, the air goes to the expander, and this process is 3 to 4, and this is also isentropic expansion process. So as you can see, S3 is equal to S4. So in the expansion, the volume increases and the pressure decreases from P3 to P4. Okay, and this temperature reduces from T3 to T4. Okay, the temperature is reducing. Then it goes to the evaporator, that is the refrigerator. So the process 4-1. So as you can see over here, the process 4-1 is having the same pressure, like P1 is equal to P4. That's why this process 4-1 is called isobaric heat absorption. So your heat is absorbed. Okay, as you can see, this is refrigerator. So heat gets absorbed. So it is called as isobaric because the pressure is same. P1 is equal to P4, but the volume has increased. Okay, and as you can see, from 4 to 1, the temperature has increased from T4 to T1. So the total process is from 1 to 2, this is isentropic compression. From 2 to 3, this is isobaric heat rejection process, and from 3 to 4, it is isentropic expansion process, and from 4 to 1, it is isobaric heat absorption process. So as you can see over here, if we discuss only PV diagram, so this is isentropic compression where S1 is equal to S2. So pressure increase, volume decrease, and 2 to 3 pressure remains same, P2 is equal to P3, but volume decreases. From 3 to 4 the pressure decreases, volume increases, and from 4 to 1 pressure remains same, P4 is equal to P1, but the volume increases from P4 to from V4 for V1. So here if we discuss only TS, so as we can see from 1 to 2 that entropy is same, S1 is equal to S2, and here the temperature decreases from 2 to 3 because the process takes place in heat exchanger, that is the cooler. So we can see the temperature as reduced. Then T3 to T4 the entropy remains same, so that's why S3 is equal to S4, but the temperature decreases. And then from 4 to 1, which takes place in the evaporator, that is the refrigerator, so the temperature, because the heat is also absorbed, so temperature increases from T4 to T1. So this was Bell-Coleman air refrigeration cycle. Hope you like the video. We will again meet in the next video very soon. Till then, goodbye.